Welcome back. This is the second lesson recording for IM2 week 7 of distance learning. Now we're going to be talking about volume of 3D objects like prisms and cylinders. So to begin, what is volume? It's really the same as asking how much bread do we have? What is the amount of space taken up by this bread? And you might be telling me, oh, I know that. Volume is length times width times height. So in a simple prism, it will be length times width times height, and that will be correct. However, to be able to generalize, we want to consider how we got this equation or formula, and to consider that, we are going to look at slices, the bread as slices, and how much bread is in each slice. So if I take one slice and put it in this hypothetical base area, then we are asking how many of this unit cube, how many of these cubes fit into this slice of bread. And that unit cube is made up by the same height as one slice of bread, and each of the cube is being made by the width and the height and the length being the same as the height of one slice of bread. So how many of this unit cube fits into this one slice? Then you might break this into, okay, there are 5 of these across and 4 of this way. So I had this one slice is made up by 5 times 4, which is 20 of these tiny little cubes. Then you might be thinking, okay, that's one slice. So how many slices make up the whole loaf? I can say 3, 4, 5, 6, 7. Say we have 7 slices that make up the whole loaf. Then if that is the case, we know one slice area, the volume of one slice, is just going to be length times width. Why? Because the height is just 1. And then you multiply that by how many slices do we have? We have 7 slices. So volume of bread is going to be volume of one slice times number of slices we have. It is still the same as length times width times height, because this is going to be length times width times height. But we want to be able to generalize. So from here, length times width times height now becomes volume of B, big uppercase B, which represents the area of the base. So area of one slice of bread, and then multiply by how many slices do I have, and that is the height. So we have just generalized this formula into volume is going to be the base area times height. Why did we do that? Well, we can apply this to any shapes of prism. So in this case, we have triangular prism, and we can divide this up into many different slices to figure out what the volume is. So we have one slice being made up by a triangle, and the height, we have say 9 slices of those base triangles. Then volume is going to be area base, area of the base area of this triangle times height. And the base, the shape of this base is going to be triangle. So if you have this dimension 6 times 5 as a triangle, then the area of the base is going to be half times 5 times 6, which is 15. And we know that height is 9 units. So we're going to multiply the base area for 15 times the height, which is 9, which gets us to 135 unit cubed. Okay, so let's consider a more complicated shape. So the first thing you need to do when you see this shape is this a prism? Well, it's a prism if you have 2 parallel sides that are identical, and that is being connected by a certain height. So the height of this prism is 12. So the base shape is trapezoid. I hope you are starting to be able to recognize that. The trapezoid is the base shape. And how do we figure out the area of the trapezoid? It is going to be the average of the two different lengths. So 5 plus 8 divided by 2, then multiply by the height. That is how we get the area of a trapezoid. So it's going to be half times average of 5 plus 8. So add those two lengths together and divide by 2, and then multiply that by the height. And that gets you 26 units squared. And that's the base area, and then we're going to multiply that by height, which is 12, so that gets us to 312 unit cubed. Let's apply these two cylinders now. Well, volume is going to be base area times height. What is the base area in this case? It's a circle. If I cut it into slices, it's going to be many slices of circles. So, and it has the height of 10. If I look at the circle alone, what is the base area of the circle? It's going to be pi r squared, so that's going to be pi 4 squared, which is 16 pi. And then volume is going to be 16 pi, the base area, multiply that by height, which case is 10, so 160 pi. I want you to make sure that you recognize that the base area and the height, they are always perpendicular to each other. Okay, so they make 90 degrees to each other. I want you to be able to visualize that, because that is the key to making sure that you're multiplying the correct numbers. Okay, so then what about this shape? Volume of a prism or cylinder is always going to be base times height, or base area times height. So specific to cylinder, you have a different formula, because we know that area of a circle is going to be pi r squared, then multiply by h. That's the height. Alright, so then you have a couple of try it now problems. So please pause the video and solve these. But make sure when you're calculating the volume of the figures below, you identify the parallel bases first. They have to be the same size and they have to be parallel to each other. And identify the height that connects the two parallel bases. Okay, please pause the video now and do these problems, and I'll show you the answers. Okay, the parallel bases are the top and bottom rectangle. So I chose this top and bottom to be my parallel bases. You could have chosen many different, you could have chosen this face and this face, or you could have chosen this front and the back face, but I chose the top and bottom. And the top, the base area is going to be 4 times 8, which is 32. And then the height is going to be multiplied that by 8. So the volume is going to be 32 times 8, which is 256. Okay, for B, I showed you the answer earlier, which was my mistake. But again, you get to figure out what is the top and bottom circles. They are the bases. So area of the base is going to be pi 8 squared, which is 64 pi centimeter squared. Height, what is the height that connects the two bases? That's 5 centimeters, and the volume is just 54 pi times 5, which is 320 pi cubic centimeters. What about this? Can you try these problems now? Pause the video. Okay, how did you do? So again, the parallel bases. The parallel bases are the triangles, isn't it? The two triangles, two right angle triangles connected by the height of 2 feet. So the base area is going to be half times 4 times 3, which is 6 feet. And the height is 2 feet. And so the volume is 6 times 2, which is 12 feet cubed. For this is a trapezoid prism again, because you have the front and back trapezoids that are parallel to each other, identical in size, connected by the height of 8 feet. Okay, so what is the base area? Again, base area of a trapezoid is going to be the average of the two lengths of the trapezoid, two different lengths of the trapezoid, two parallel lines. And so that's going to be 11 plus 4 divided by 2. So that's going to be 15 divided by 2, or 7.5. Multiply that by the height, which was 8. Height of the trapezoid was 6.1. And then height of this prism is 8 feet. So you multiply it all together and you should have gotten 366 feet cubed. Okay, so what about this problem? If you have this some weird shape and you are told the area is 10 unit cube squared, 10 units squared, then can you figure out the volume? Well, since we know that the base area is 10, you just need to multiply by height, which is 20. So 10 times 20 is 200 unit cube. So that's what you should have gotten. Okay, I am going to end this recording here.